Bismillahirrahmanirrahim. My name is Salam and my topic of presentation is hexadecimal to decimal conversion. First of all, here is the list of contents: the hexadecimal system, use of hexadecimal system, representation of hex numbers, decimal number system, decimal notation, representation, the relationship between both, how to convert hex to decimal, and then finally some examples of conversion. First of all, the information or origin about hexadecimal system. Hexadecimal system, the word is derived from the Greek root hex meaning 6 and the Latin root decim meaning 10. And in mathematics and computing, the hexadecimal is a positional numeral system that represents numbers in the base of 16, radix, or you can call it radix. Unlike the common way of representing, the former number system of a hexadecimal system was a decimal number system, and it only included 10 digits, which were used to represent the corresponding 10 digits or numbers. Yes, but in hexadecimal system, 16 digits were used to represent different numbers, and the first 10 actually 0 to 9 represent value 0 to 9, but then A to F represent numbers of capital A and to capital F, and small a to small f represents values from 10 to 15. 15 is the highest value in the hexadecimal system, and 10 to 15 were not included in decimal system. Different computer designers and programmers use hexadecimal system to simplify binary codes into a human-friendly appearance or nature of digits. Computers, yes, this is the main point, that computers do not use hexadecimal system. It is only used by humans, and it is designed for humans just to simplify and shorten binary binary digits, figures to more easily form that is understandable by humans. It is just a convenient way. So hexadecimal, this is also an important point, that hexadecimal system is must translated into binary for computer use, because computer, we know that only works in binary digits, zeros and ones. It doesn't understand the language, so hexadecimal information has to be translated into binary digits for usable by computers. Further use, hexadecimal system is used in after encoding base 16, in which each byte of the plain text is broken. Each byte contains 8 digits, 8 binary digits, and using hexadecimal system, we can break each byte into only just into 4-digit value, and then it is only represented by 2 hex numbers. So in other way, we are trying to simplify the binary coded value that was just described in the previous slide, and each hexadecimal digit represents 4 bits, also known as nibble or nibble. Half a byte is also called nibble or nibble, and this is an example for you all to understand it. A single byte can have a value ranging from 8 o's to 81 in binary form. Binary only includes o's and ones, which can be conveniently represented as 0, 0 to FF in hexadecimal. 0 is the whenever there is a 8-digit figure, we can only write into 2 digits only in hexadecimal system, and 0 is the lowest most, and F is the highest language in the hexadecimal system. F represents 15. Representation of hexadecimal numbers. Subscript is usually used, as we all know, to specify base in mathematics. For example is given that a decimal value 55.027 is expressed in decimal as D6F3, and then a subscript representing 16 is added at the end of the figure. 16 is added in the base, but in programming, we use different Notations are used to denote hexadecimal numbers, usually involving a prefix or suffix. We use the prefix means we use something before the hexadecimal number figure, or suffix we denote something. We represent hexadecimal number by writing something after the figure. The prefix 0x is used in C. Okay, C is one of the most common widely used programming languages in the world, and we use prefix 0x in order to represent a hex value in the programming. In the above example would be rewritten as 0xd6f3 in the language C. Now the decimal number system is also called Hindu Arabic or Arabic number system, and it is a positional number system requiring 10 different numerals from 0 to 9. They make 10 numerals, and it also requires a dot, which is called decimal point to represent decimal fractions. Of course, as the name suggests, decimal, so it obviously involves decimal point or dot. Decimal notation or representation. For writing numbers, the decimal system uses 10 decimal digits that I said is 0 to 9, a decimal mark, or for negative number you have a negative sign, which is minus. So you put that before the figure. And the decimal digits are 0 to 9. The decimal separator is the dot. Okay, every country has its own way of expressing different terms of figures. So in many countries, the decimal separator is written in the form of dot, but in many countries it's also written as comma. The relationship between both. Okay, this is the table that I made to explain the correspondence of numbers between decimal and hexadecimal system. From 0 to 9, the numbers are same in hexadecimal and decimal. They represent exact 0 to 9 in both systems, but from 10 to 15 are not included in decimal system. I have written into, but it is just for convenience that I cannot make another table. So 10 to 15 digits are not included in decimal table in decimal system, and they are only included in hexadecimal, but they are represented in hexadecimal system as A, B, C, D, E, F for 10, 11, 12, 13, 14, 15 respectively, and the capital and the small letters both work. So this is our main topic, convert hexadecimal to decimal. This is the main topic, and I thought to give you prior knowledge about hexadecimal system and decimal, but our main topic starts here. How to convert hexadecimal to decimal system? Okay, it is very easy. These are just the simple steps to follow, and then you will make it out. Here are the steps to convert hexadecimal. We get the decimal equivalent of the hex from table F. You can write all the equivalents of decimal number or hexadecimal to decimal to hexadecimal, and you just tally your number from that table, and it will make all the things easy. Multiply every digit with the 16 power of digit location 16 and the power of location of digit. In 7D, E location is at 0, D is at 1, and the 7 is at 2, so you have to multiply 16 with the power of that location of digit, and sum all the multipliers, and we have a figure in decimal number system. Here is an example. 7D, E, show each digit place as in the power of 16, so we have to just each digit multiply with 16 and the power of location of that digit, and sum them all, and then we get at the end 2014. This is in the decimal system. Other example is 23E, as E is equal to 14.5. So 23E to 14, and exactly the same procedure carries on. 2 into 16, and the power is the location of that figure, that digit in the figure. Then multiply them and sum them all. 574 is the decimal number digit in decimal number system. F As represents 15 in hexadecimal system, so we have to just multiply them all, and then their sum is equal to 65535 in the system, decimal system. 65535 is the decimal equivalent of FFFF. The last example, 887 is exactly the same procedure. It's very easy conversion. Convert each hexadecimal digit and to decimal values and perform the math. 10 into 496 plus 3 into 56 plus 7 into 16, and then we get the value of 41854. And this is the decimal equivalent. I hope you all understand it. And if you have any question, then do let me know in the comment section. Thank you.